Hello everyone, today I'm going to be talking about the single slit diffraction. I'm going to do a problem and then test it out in the PHYS simulation to see if the equation actually works. So let's just say that there is a light that shoots out a light wave at a wavelength of 500 nanometers. Okay, and then it goes through a single slit and onto a screen. Now let's say that the single slit, the length of it is 1600 nanometers. Okay, so and it will ask how many dark fringes are there. How many dark fringes? In that case, we would just look in the equation sheet and we would quickly find that there is an equation specifically for this that says W sine theta equals the power times wavelength. And in this case, we are looking for the m because the m correlates to the power. And when you look at a wave intensity chart, let's say this is an intensity chart right here, each power is correlated to the number of dark hinges. So 1, 2, 3. Now, so in this case, what we would do is that we would plug in everything that we know so far. So the slit length is that 1600. In this case, theta can be 90. We're solving for m, and wavelength is 500 nanometers. And we can cancel out the nanometers. Since sine 90 is 1, we can cancel that out. And so 16 over 5 or equals to 3.2. Now, since you can't have 3.2 dark hinges, we just round it down to 3 dark hinges. So now let's compare it to the simulation. Okay, so now here we have a simulation to test if our hypothesis is true. So over here we have a wavelength of 500 nanometers. Here's our intensity chart, and here's the slit width set to 1600, which is the maximum here. And we can see if there are going to be 3 bright hinges or not. So when we shoot the light, as you see, now it diffracts as it passes through the slit. And as you can see, as the light comes in, we could see 1 bright hinge, 2, 3, which basically proves our point that this equation works in this scenario and that there are 3 dark hinges. And whenever you see a problem like this, let's say on a test, just use the W sine theta equals m wavelength and you should get the correct answer. Thank you for watching.